Hi, this is Aravind Balaji, and this is chapter 9 of Grounding Agents in Evidence. This is Magid's Newsroom RAG system. Let me draw first. Here is the architectural claim. Most people think RAG is a search optimization. You give the model better context, so it gives better answers. That's wrong. RAG is an epistemological constraint. It does two things. First, it establishes a bounded reference object, the journalist's source document. The model can only work from that document. Second, and this is the actual insight, that bounded object makes deviation measurable. You can now compute how far the output drifted from the source. Without the second step, the first step produces no trust benefit. You have a reference you never check. Most teams build RAG and stop. Maggots build the measurement layer. Let's draw again. So these are the five boxes, and these represent the architecture. The stage 1 is the knowledge boundary. The agent works only from the journalist uploaded document, nothing from pre-trained knowledge. This is the most important stage. Stage 2 is the task decomposition. The prompt layer orchestrates specialized agents. One extracts facts, one transforms for the platform, one checks bias. The stage 3 is generation. The platform specific outputs like web, social, push, and translation. Stage 4, this is where the most teams have nothing. The 3-axis scorer. Code fidelity, attribution, accuracy, semantic fidelity. Each axis catches a different failure mode. This is the This is the 0.62 to 0.75 gap. The gap between what token overlap catches and what semantic similarity misses. And stage 5 is the real-time observability. Galileo monitors every story. And this is the human decision node. The human sets the review threshold. The human decides what failure costs the institution cannot accept. Now the failure mode this design prevents. If you remove stage 4, the measurement layer, what happens? The model still generates, the output still looks professional, but nobody measures whether the output matches the source. The failure mode is unfaithful generation from faithful retrieval. The retriever gets the right document. The generator produces fluent text that subtly deviates, a paraphrased quote presented as direct, a statistic attributed to the wrong source, a qualifier dropped. At 3% deviation across 300 stories a day, that's 9 errors per day, none detected. When one reaches publication, the team blames the model and replaces it. The error rate drops from 3% to 2.1%. The measurement layer is still absent. The architectural deficiency is preserved. The model was blamed, the architecture was the cause. Let me show you this in the notebook. Same model, same embeddings for all pipelines. The model is not the variable. Let me run the first cell. And now I'm running the setup cell. This is just the Hugging Face model. What we need is the setup is complete, the same LLM and embeddings for all pipelines. Next is the part 1, the worked example. Let me run this. The fabricated RAGAS code. Source, RAGAS stopped short of endorsing. Output, I support bringing more housing. Same person, reverse position. The utility functions are loaded. Now let me run the checkout cell. There is token overlap. Only 4 tokens in common out of 31. The hedging birds are gone. The token deviation is 0.844 and the semantic deviation is 0.483. The token deviation is flagged and the semantic deviation is not flagged, and delta is 0.361. Token overlap catches it. Semantic similarity misses it. The gap direction is stable across embedding models. The extract magnitude varies, but the pattern holds. Topically coherent fabrications always score high on semantic similarity. The broadcast script. 3 codes, 2 statistics, 1 qualifying statement. Let me run the cell. The output looks professional, but did it change any codes? We don't know. Pipeline A doesn't measure. Now pipeline B, same script, same model, but with 3-axis scorer. Let me run it and show you. This is the pipeline A. the pipeline B. So pipeline B says scorers are defined. So the pipeline B is running here. Let us wait for it to run. And this is the pipeline B output. The code fidelity is 2 on 5, the attribution accuracy is 3 on 5, and the semantic fidelity is 2 on 5, and the decision is to flag. Same model, the difference is measurement architecture. Part 5. This is the human decision node, which is mandatory. I'm going to stop here and tell you about a specific correction I made. Now I'm going to run this. And here is the comment block. The AI proposed using generic RAGAS context adherence as the evaluation metric. The exact proposal used RAGAS context adherence scoring, embedding cosine similarity between generated output and retrieved context. I rejected it because the worked example we just ran probe is insufficient. The gap is the evidence. The cosine similarity scores the fabricated RAIS quote as high adherence. Same person, same vote, same topic. Semantically, it is close. Journalistically, it is a misquote that could end a career. So instead of generic RAGAS, I built a 3-axis scorer. Axis 1, quote fidelity catches fabricated directed quotes. Axis 2, attribution accuracy catches wrong source errors. Axis 3, semantic fidelity catches framing shifts. Each axis maps to a different failure mode. A single cosine score conflates them all. 3 axes give diagnostic information. You know what kind of failure happened, which tells you what architectural fix is needed. That's the correction. Generic RAGAS was the AI's proposal. Domain specific 3 axis scoring was my correction. The cap was my evidence. So let me type flag and the notebook stopped. It required a human decision before proceeding. That is the architectural analog of Magid's stage 5 review threshold, where domain expertise, not computation, determines whether the output ships. Now the proof of measurement matters. I am running the real scorer on pipeline A's unscored output retroactively. Let's run the part 6. So these are the deviations found. The code fidelity is 5 on 5, the attribution accuracy is 5 on 5, the semantic fidelity is 4 on 5, and the decision is a pass. These existed in pipeline A the whole time. Without the scorer, they were invisible. These were the token deviation, the semantic deviation, and the gaps. So now let's run part 7. Two temperature settings, neither has measurement. Model A, temperature is equal to 0.5, and model B is equal to 0.1. The better model might have few errors, but without measurement, neither knows. The architectural deficiency persists across model swaps. Now let's see the comparison. Let me run the part 8. So this is the comparative analysis. Same model, same script. Pipeline A has 0 deviations detected because 0 were measured. Pipeline B, the deviations found were 5, which were scored. Architecture is the leverage point. So this is the author's note.md. The author's note documents every tool interaction, 3 bookie corrections quoted verbatim, 8 eddy passes with 19 fixes across 10 standards, 8 figure architect figures rendered, case structured case analysis. This is the full audit trail. Here is the one modification that breaks the system, which is the scorer being disabled. Replace the 3-axis scorer with this function scorer disable. It always returns pass. Perfect scores on every axis. This simulates what most production RAG systems actually have, no measurement layer. Run pipeline A with this function, the output ships without any check. Now run the real scorer retroactively on the same output. The deviations appear. Fabricated codes, shifted attributions. Every one of them would have reached publication. That's the failure mode. Not a system that doesn't work, a system that appears to work while silently misrepresenting its sources. The scorer was the only thing standing between the output and publication. Remove it and you have pipeline A. You have no measurement. You have the 5-stage failure anatomy. Your exercise: clone the repo, replace the scorer, count the deviations that would have shipped. Let me run this for a better understanding. The open question this chapter does not fully resolve. How do you know your scorer is correct? The scorer uses an LLM to evaluate fidelity, but the LLM has its own failure modes. Sycophantic scoring, prompt sensitivity, threshold miscalibration. The chapter documents these in section 5.2, but it does not give you a number for how often the scorer itself is wrong. Magid's answer is expensive but honest. 100 plus human graded stories per station as ground truth. IBM Watson shows what happens when you skip this step. Trained on synthetic cases deployed against real patents, unsafe recommendation invisible to its own metrics. Your first 100 human graded evaluations are the most valuable architectural investment you can make. They are what turns trustworthy from a marketing word into a checkable claim. But even that corpus goes stale. New story types emerge, editorial standards shift, the evaluation metrics themselves drift. What evaluations or who evaluates the evaluator? That's the question section 8 raises and doesn't close. RAG is not a search optimization, it is an epistemological constraint. Context adherence is measurable, but only if you measure it, and the measurement must be calibrated to the failure modes that matter in your domain. Architecture is the leverage point, the model just executes the architecture you designed. Thank you.